In this lecture, we will discuss about Maclaurin series. This series used for expansion of functions. So the statement of this series, let fx be a continuous function and its derivative up to nth and higher order exists. So then function of x, fx is equal to f naught plus x into f dash naught upon factorial 1 plus x square upon factorial 2 into f double dash naught plus x cube upon factorial 3 f triple dash naught plus and so on. General term will be x raised to the power n upon factorial n fn naught plus and so on. So this is the statement of Maclaurin series. Now we prove the Maclaurin series. So the proof of Maclaurin series, let us assume that fx is equal to a naught plus a1x plus a2x square plus a3x cube plus a4x raised to the power 4 plus a5x raised to the power 5 plus and so on, where a0, a1, a2, a3 are constants and to be determined. So we also determine the value of a0, a1, a2, a3, n. So for determining the value of a0, a1, a2, a3, n, so we start the differentiate 1 with respect to x. So the first derivative is f dash x is equal to, the a naught is purely constant term. The differentiation of a naught is 0 and a1x. So a1x differentiation of x is 1. So a1 plus the second term 2a2 into x square differentiation to x plus third term 3a3 into x square plus 4a4 into x raised to the power 3 plus 5a5 x raised to the power 4 plus and so on. So this is our equation 2. Now differentiate equation 2 with respect to x, means again differentiate. So differentiation of f dash x is f double dash x. So f double dash x is equal to a naught, a1 is purely constant, so differentiation is 0. So we write down 2a2, differentiation of x is 1. Now plus next term is 3 2 just 6. So 6 a3 into x plus 4 3 is 12, 12 a4 into x square plus 5 4 is 20, 20 a5 into x cube plus and so on. So this is the equation number 3. Now we differentiate again. So again differentiate with respect to x. So again differentiation, that means f triple dash x is equal to 6a3 plus 12 to the 24, 24a4 into x plus 23 is 60. 60 into a5 or x square plus and so on. So this is our equation number 4. Now again differentiate. So we write down that f dash f4 times x is equal to 24 a4 plus 120 a5 x plus and so on. So this is the equation number 5. Now when we see the statement of Maclaurin theorem, so we have prove fx is equal to f naught, f dash naught, f double dash naught, f triple dash naught. So for proving the Maclaurin series, we put x is equal to 0 in equation 1, 2, 3, 4 and 5. We get, so when we put x equal to 0 in 1, so we see that f naught is equal to a naught. So other than a naught, each term having the x square, x cube. So other term will be 0 while putting x equal to 0. So f naught is equal to a naught we get from equation number 1. From equation number 2, so we see that so f dash naught equal to a1. From equation number 3, f double dash naught is equal to 2a2. So here we can write down the value of a2. a2 is equal to f double dash naught upon 2. This f double dash naught can be written as factorial 2. Okay, 2 can be written as factorial 2. From third equation, so we see that f triple dash naught is equal to 6a3. 6a3. So because each term having x, so will 0. So we can write down as a3 is equal to f triple dash naught upon 6, or this 6 can be written as factorial 3. Factorial 3. Now in equation number 5, so when we put x equal to 0, so fourth derivative of this gives us 24a4. Next term will be 0. Each term contain x other than 24a4. So now when we calculate the value of a4, so this gives us f4 naught upon 24. So 24 will be the factorial 4. Factorial 4. Now, okay, so we can calculate fifth derivative and sixth derivative and so on. So now we put the values of a naught, a1, a2, a3, a4 in equation number 1. So when we put the value of constants in equation number 1, so we see that, so equation number 1 is this, so fx is equal to, so this fx is equal to a naught. So a naught value is f naught. So a naught value is f naught plus, next is a1x. So a1 value is f dash naught into x plus a2 x square. So x square into a2, value of a2 is f double dash naught upon factorial 2 plus a3 x cube. So a3 x cube, a3 x cube, so x cube into a3. The value of a3 is f triple dash naught upon factorial 3 plus a4x raised to the power 4. So x4, so fourth derivative 0 upon factorial 4 plus and so on. So this we can write down as fx is equal to f naught plus x upon factorial 1, you can write down as f dash naught plus x square upon factorial 2, f double dash naught plus x cube upon factorial 3, f triple dash naught plus x4 upon factorial 4, f4 naught plus and so on. So this is our Maclaurin series. This is our Maclaurin series. So we use this Maclaurin series for expansion the function. So expand the functions. Generally, teacher says that you remember the expansion of sine x, cos x, e raised to the power x. So if we want to prove or we want to obtain the expansion of these functions, so we can easily obtain by using this Maclaurin series. Okay, so we shall start with the first one. So question number 1, expand sin x. Expand sin x. Uh, First we write down when we remember the expansion of sin x. So what is the expansion of sin x? So the expansion of sin x is x minus x cube upon factorial 3 plus x raised to the power 5 upon factorial 5 minus x raised to the power 7 upon factorial 7 plus and so on. Now here we have to prove that. So what is the expansion of sin x? So we use the Maclaurin series. So here we write down the solution of this. So when we have not remember this expansion, so we can obtain this relation by using the Maclaurin series. So here we take as let fx equal to sin x. So this is our equation number 1. Now differentiate 1 with respect to x. So one differentiation of x is f dash x is cos x. This is our equation 2. Again differentiate. So we differentiate this 3 to 4 times for finding the expansion that we write at least 3 to 4 terms of the series. So f double dash x, differentiation of cos x is minus sin x. So this is equation number 3. Again differentiate with respect to x. So again differentiate. So f triple dash x, is equal to minus cos x. Differentiation of sin x is cos x and minus sin is positive. So again differentiate with respect to x. So we write down the f for x is equal to sin x. So differentiation of cos x is minus sin x, so minus minus plus. So this is equation number 5. Again differentiate. So we see that f5x, so fifth derivative of this is equal to cos x. So we differentiate 5 times. Okay. Now we put x is equal to 0. X equal to 0 in 1, 2, 3, 4, 5 and 6 we get. Okay. So we have proved the Maclaurin series at x equal to 0. So we put x equal to 0 in 1, 2, 3, 4, 5, 6. So we get the value from 1. What is the value from 1? So when we put x equal to 0, so f0 is sine 0. So f0 equal to sine 0. So f0 is equal to sine 0. So what is the value of sine 0 is 0. Now in second, f dash 0. F dash 0 is equal to cos 0. Value of cos 0 is 1. F double dash 0 minus sine 0. Minus sine 0 means 0. F triple dash 0. F triple dash 0 equal to minus cos 0 means minus 1. F 4 times 0. So this equal to fourth derivative is sin x. So means sin 0 is equal to 0. And fifth derivative is fifth derivative at 0 is equal to cos 0. So cos 0 equal to 1. So we obtain these values. Now put these values into the Maclaurin series. So now the Maclaurin series is fx is equal to f naught plus x f dash naught plus x square upon factorial 2 f double dash naught plus x cube upon factorial 3 f triple dash naught plus x raised to the power 4 upon factorial 4 f4 naught plus x raised to the power 5 upon factorial 5 f5 naught plus and so on. Now, what is the value of fx? The value of fx is sin x. Sin x equal to f naught. F naught is 0 plus x into f dash naught 1 plus x square upon factorial 2 f double dash naught 0 plus x cube upon factorial 3 f triple dash naught minus 1 plus x4 upon factorial 4 f4 naught is 0 plus x5 upon factorial 5 f5 naught is 1 plus and so on. So we write down the expansion of sin x. Sin x is equal to x minus x cube upon factorial 3 plus x5 upon factorial 5 minus and so on. So this is the expansion of sin x. We can easily obtain the expansion of cos x. We can easily obtain the expansion of e raised to the power x. Okay, so try to solve the questions related to that. So what is the expansion of cos x? The expansion of cos x, we have 1 minus x square upon factorial 2 plus x raised to the power 4 upon factorial 4 minus x raised to the power 6 upon factorial 6 plus and so on. So this is the expansion of cos x. So we can prove similarly. Okay, we can prove similarly. And expansion of e raised to the power x. So the expansion of e raised to the power x is 1 plus x square upon factorial 2 plus x cube upon factorial 3 plus x raised to the power 4 upon factorial 4 plus and so on. So we can prove these expansions easily by using the Maclaurin series. Also, you can remember the expansion of 10x. So what is the expansion of 10x? Expansion of 10x is x plus x cube upon 3 plus 2 x raised to the power 5 upon 15 plus and so on. Okay, so try to solve these questions. Now we move to the further problems related to Maclaurin series. So the next question is expand e raised to the power x into sin x in powers of x as far as x raised to the power 5 means fifth term as far as x to the power 5 by using Maclaurin series. By using Maclaurin series. So we assume that fx is equal to e raised to the power x into sin x. So this is our equation number 1. So we differentiate this with respect to x. So f dash x is equal to e raised to the power x into sin x plus e raised to the power x into cos x. Now again differentiate f double dash x. So again we use the product function e raised to the power x into sin x plus e raised to the power x into cos x plus for second term e raised to the power x differentiation of into cos x plus e raised to the power x into minus sin x. So this equal to e raised to the power x into sin x. So e raised to the power x into sin x to sin x cancelled, or this gives us 2 e raised to the power x into cos x. 2 e raised to the power x into cos x. So this is our f double dash x. Now differentiate again. So we have f triple dash x is equal to 2 e raised to the power x into cos x or plus e raised to the power x into minus sin x. So this is the third derivative. Now differentiate again. So f(4x), fourth derivative, twice of e raised to the power x into cos x plus e raised to the power x into cos x differentiation is minus sin x plus. So here is e raised to the power x into minus sin x or plus e raised to the power x or differentiation of sin x is cos x. So e raised to the power x into cos x, e raised to the power x into cos x will cancel. So this gives us minus 2 e raised to the power x into sin x. So this is our fourth derivative. Now differentiate again. So fifth derivative of this is equal to minus 2 e raised to the power x into sin x plus e raised to the power x into cos x. Okay, so we write down this as equation number 2. This is equation number 3, second derivative. This is equation number 4, third derivative. Equation number 5 and equation number 6. So same thing we do. That means put x is equal to 0 in 1, 2, 3, 4, 5 and 6. So we get, so when we put x equal to 0 in 1, so this gives us f naught equal to e raised to the power 0 is 1 or sine 0 is 0. So f naught is 0. So f naught is equal to e raised to the power 0 into sine 0. So e raised to power 0 into 1 or sine 0 equal to 0. So this gives us 0. Second, f dash naught. F dash naught. So f dash naught means e raised to the power 0 into sine 0. So e raised to the power 0 into sine 0 plus e raised to the power 0 into cos 0. So this gives us 1 into 0 plus 1 into 1 equal to 1 cos 0 1 f double dash naught. So the value of f double dash naught, the 2. So this gives us 2 e raised to the power 0 into cos 0. So 2 into 1 into 1 equal to 2 f triple dash naught. F triple dash naught, third derivative. Third derivative is 2 into e raised to the power 0 cos 0. So 2 into e raised to the power 0 into cos 0 or plus e raised to the power 0 into minus sine 0. So sine 0 is 0, cos 0 is 1. So this gives us 2 into 1 plus 0 is equal to 2. Or f fourth derivative, f40 is equal to minus 2 e raised to the power 0 into sine 0 equal to 0. Fourth derivative is 0 and the fifth derivative means from equation number 6. So minus 2 into e raised to the power 0 into sine 0 plus e raised to the power 0 into cos 0. So this gives us minus 2. Sine 0 0, cos 0 1, so minus 2. So now by Maclaurin theorem, fx is equal to f naught plus x, f dash naught plus x square upon factorial 2, f double dash naught plus x cube upon factorial 3, f triple dash naught plus x raised to the power 4 upon factorial 4, f4 naught plus x5. So we have to prove this up to fifth term into f5 naught plus and so on. So we no need to write further and so on, but when we calculate this fifth term, so we write and so on, okay, because this is a continuously. Now fx is e raised to the power x into sin x plus f naught. What is the value of f naught? F naught is 0. F naught is 0. So this equal to. So this equal to 0 plus x into f dash naught. What is the value of f dash naught? F dash naught is 1. F dash naught is 1 plus x square upon factorial 2. F double dash naught is 2 plus x cube upon factorial 3. X cube upon factorial 3 f triple dash naught is also 2. X4 upon factorial 4 f4 naught equal to 0 plus x5 upon factorial 5 f5 naught is minus 2 plus and so on. Now we simplify this. So e raised to the power x into sin x is equal to x plus x square. This 2 to factorial 2 cancelled, and plus next term will be x cube upon, here is factorial 3. Factorial 3 means 6. So 2 3s are 6 plus this will be 0 and this is minus sign. So this is the negative sign. So we write down this as minus x5 upon factorial 5. Value of factorial 5 is 120. So 2 say 60 times this will be cancelled. Then next term will be plus and so on. So this is the expansion of e raised to the power x into sin x. Okay. Second formula we can use for expanding this by using the nth derivative. So you remember the formula of nth derivative. So that means dn of e raised to the power x into sin x. So you write down the nth derivative of this and put n equal to 1, 2, 3, 4, 5. So then we can get the first derivative, second derivative, third derivative, fourth derivative easily. Okay, so we can use nth derivative also. Now we take one more problem related to that. Expand log 1 plus e raised to the power x by Maclaurin theorem. Sorry, Maclaurin series. So here we use as fx. Fx is equal to log 1 plus e raised to the power x. So this is our equation number 1. So when differentiate 1 with respect to x. So we have f dash x equal to differentiation of log x is 1 upon e raised to the power x into differentiation of this is 0 plus e raised to the power x. So this gives us e raised to the power x upon 1 plus e raised to the power x. So this is our f dash x. So this is equation number 2. Now differentiate again. So when we differentiate this and differentiate again, so this gives us f double dash x equal to, so we use the numerator upon denominator formula. One denominator into differentiation of numerator is e raised to the power x minus numerator, and differentiation of denominator is 1 plus 0 plus e raised to the power x upon denominator to the whole square. So this gives us 1 upon 1 means e raised to the 1 into e raised to the power x upon 1 plus e raised to the power x to the whole square. Because this term, this is the negative sign, this is the positive sign, so this term will be cancelled, and we get the e raised to the power x upon 1 plus e raised to the power. So we write down here this as, so this is e raised to the power x upon 1 plus e raised to the power x to the whole square. So this is our equation number 3. So now we obtain the third derivative. So the third derivative means again differentiate. So this gives us f triple dash naught is equal to. So when we differentiate this again, so same form. So we write down the denominator into differentiation of numerator, it means same, minus numerator differentiation of denominator. So 2 into 1 plus e raised to the power x, and the differentiation of this 0 plus e raised to the power x to the e raised to the power x upon denominator to the whole square, means raised to the power 4. Now in numerator we take 1 plus e raised to the power x as common. So the first term gives us e raised to the power x into 1 plus e raised to the power x minus 2. 2 e raised to the power x, and e raised to the power x means e raised to the power 2x. So e raised to the power 2x upon 1 plus e raised to the power x raised to the power 4. So one power will cancelled from numerator. So this gives us e raised to the power x into 1 plus e raised to the power x minus 2 e raised to the power 2x upon 1 plus e raised to the power x raised to the power 3. So this is the third derivative. This is the third derivative. So this is our equation number 4. So we can calculate another derivative, fourth derivative, fifth derivative. So okay, so here we write the x. So we write this as x and also write the x. Okay, so now we put x is equal to 0 in 1, 2, 3, 4. So put x is equal to 0 in 1, 2, 3, and 4. So we get, when we put x equal to 0 in 1, so we get x equal to 0 in 1. Log 1 plus e raised to the power 0 means 1. So log 1 plus e raised to the power 0. So this gives us log 1 plus 1 is equal to log 2. So this is log 2. Now we find the first derivative when we put x equal to 0. So f dash naught equal to, so what is the value of first derivative? E raised to the power x upon 1 plus e raised to the power x. So we write down e raised to the power 0 upon 1 plus e raised to the power 0. So this gives us 1 upon 2. F double dash naught. So e raised to the power 0. So e raised to the power 0 upon 1 plus e raised to the power 0 to the whole square. So 1 upon 1 plus 1 to the whole square means 1 upon 4. F triple dash naught. F triple dash naught equal to, so in this term we write down as e raised to the power 0 into 1 plus e raised to the power 0 minus 2 into 0 upon 1 plus e raised to the power 0 whole to the power 3. So e raised to the power 0 1. So 1 into 1 plus 1 minus 2 upon 1 plus 1 raised to the power 3. So gives us 0. So 1 plus 1 is 2, 2 minus 2. So f triple dash 0 equal to 0. So the third derivative is 0. Okay. So now by Maclaurin series, fx is equal to f naught plus x f dash naught plus x square upon factorial 2 f double dash naught plus x cube upon factorial 3 f triple dash naught plus and so on. So fx is log 1 plus e raised to the power x is equal to f naught. The value of f naught is log 2 plus x into f dash naught 1 by 2 plus x square upon factorial 2 f double dash naught. F double dash naught is 1 by 4 plus x cube upon factorial 3 f triple dash naught. This is 0 plus next term will be x raised to the power 4 upon factorial 4. The fourth derivative is minus 1 upon 8 when you calculate plus and so on. So you write down this as log 2 plus x upon 2, or this gives us factorial 2 is 2, so plus x square upon 8 minus this term gives us x raised to the power 4 upon 24 8 ja 192 plus and so on. So this is the expansion of log 1 plus e raised to the power x. Okay, hope you understand the Maclaurin series and related problems.